Hello, science students. Welcome to today's lesson about the factors of climate. As you may recall, earlier in our studies, we've described and defined weather as the atmospheric conditions for a specific place and time. So if you look outside your window, you can describe the weather for your location at that point in time. But climate is a little bit different. We've also come up with a definition that calls it the long-term average atmospheric conditions that occur in a particular region. You'll notice both of those show up as your key vocabulary terms. You'll want to make sure to get those into your notebook. Both weather and climate have some common characteristics. For instance, we can use the temperature to describe both weather or climate. We could use things like precipitation or humidity to describe both weather and climate. They both tell us about what's happening with the weather or what a place's climate is like. And weather and climate both describe atmospheric conditions. While they sound very similar, they have some differences as well. Weather, for instance, lasts a very short time, while climates last a very long time. The changes in weather occur very quickly, whereas climate changes very slowly. And then weather is very specific to a location, it's very precise, while climate is over a much larger, broader region. You also may recall that there are lots of things that can affect the weather. The temperature can change the weather, the pressure in the area can change the weather, wind, humidity, and clouds can all have effects on the weather. And each one of these things actually affects and alters the other one a little bit and determines what happens in the atmosphere on a day-to-day basis in a location that we call weather. But they also have some effects on that area's climate. Some of the major factors that affect an area's climate include its latitude, its ocean currents, its wind and air masses, the elevation, and the relief, or abbreviated as lower. Latitude, a little social studies review here, compares to your location to the equator. The equator is located at 0. Northern hemisphere is designated with positive values or the abbreviation of N for northern hemisphere. And southern hemisphere has negative values or the abbreviation of S for the southern hemisphere. And here you can see that those values start at 0 at the equator, increase as you go closer to the poles, and this helps to determine some of the areas. Areas between 0 and 30 degrees are considered tropic. Areas between 30 and 60 are temperate. And areas between 60 and 90 are polar. And these breakdowns and divisions between those three regions are based off of the amount of sunlight and the intensity of sunlight they receive. And that kind of relates back to the tilt of the Earth as we learned about in our previous unit. The sunlight is more intense when that area of Earth is tilted towards the sun, and vice versa. So the tropical zone is so much warmer than other areas because that area between 0 and 30 degrees gets the most intense sunlight for the longest periods of the year. Whereas that temperate zone receives less intense sunlight and it varies from time to time. The polar regions receive even less intense light, and it's pretty weak intensity light for the year round. The amount of that sunlight and how intense it is affects things like the surface temperature of a location, both on land or on water, the air temperature for that region, and then, of course, the air pressure and humidity. Other major factors that affect climate include the ocean currents in the area. Sections of the ocean move around the Earth. They flow just like a river has a starting point and an ending point. These currents move water from one location to another as well. And those moving rivers of water within the oceans are what we call an ocean current. Ocean currents are either warm or cold depending on what type of water they carry. A warm current carries warm water. A cold current carries cold water. That cycling of ocean currents helps to transfer energy from areas of the tropics to the poles and everywhere in between. A warm ocean current transfers thermal energy to the air above it, creating a warmer air mass and area of low pressure. So you could have ocean water that is warming up in the tropics. And warm ocean current then carries that water to a different location, like the temperate zone, where that warm ocean water transfers energy to the air and creates a low pressure zone. Vice versa, cold ocean currents absorb energy from the environment around them and cool off the area above it, creates a high pressure air mass. Here you can see the different ocean currents and whether they are warm, shown in red, or cool, shown in blue. These currents are relatively predictable and stable. They do not fluctuate as much as the air currents that we call the jet stream. Ocean currents move water both horizontally around, but as well as vertically in the water column. And you can see the difference in temperature as you go deeper and deeper into the ocean. The polar region stays about the same temperature at the surface all the way down to the deepest depths. It's about 4 degrees Celsius, which is roughly 34, 35 degrees Fahrenheit. Whereas the temperate zone starts out at about 15 degrees Celsius or about 55 degrees Fahrenheit, and then drops down to that similar, very close to freezing temperature as you go deeper and deeper and deeper. Compared to the tropics, which are very, very warm water, like 28 degrees Celsius or about 77 degrees Fahrenheit, and then it drops off pretty quickly at about that same spot to about that close to freezing temperature as you go deeper and deeper and deeper. So there are areas where water travels up and cycles up from those deep areas and creates a cool current. And then there are areas where that warm current dives down and brings some energy down deeper into the water column. We have already learned about how wind and air affect the weather and thus long-term wise the climate. Winds can move our air masses around and that can bring weather into an area, bring precipitation, changes in temperature, changes in rainfall, things like that. Or if those air masses stay put, the conditions stay relatively the same. There are three major sets of winds that follow a specific pattern in each the northern hemisphere and the southern hemisphere. Here in this diagram, you can see that the trade winds, which are found in between 0 and 30 degrees, they end up blowing kind of from that northeast down to the southwest, or generally speaking, from the east to the west. Whereas vice versa, you move up one layer into those temperate latitudes between 30 and 60 degrees, and you end up seeing that those winds reverse each other. Those winds end up blowing from the south up to the north and from the west to the east. So they generally blow the opposite direction. And then again, you can see up in the polar areas that those end up changing again and they blow back in the same direction from northeast to the southwest. And so you can see that you have some very different wind patterns. And it's all due to those convection cells that you can see above each region. Because the air rises at the equator, it falls at 30 degrees. Because that tropical air is falling at 30 degrees, the temperate air also falls at that part of that cycle. So it rotates in the opposite direction as the wind at the equator. That creates the opposite direction winds. And then, of course, you can see the convection cell in the polar region goes back to that clockwise rotation that you have at the equator. And so those winds go back to that easterly direction as well. If we review the three big ideas, you can see that we have latitude determines the temperature ranges for a climate. Tropical zones get the most sunlight due to their location in latitude. You have ocean currents that can heat or cool the air and then add or remove moisture. And then you have air currents that move these air masses around in predictable motions based on where you are at in latitude. That's as far as we're going to get on our factors of climate today. Thank you for your time and attention, and good luck on your concept check.